Good morning. Wow, interactive crowd today. Great. Thank you. You don't even need a mic. That's incredible. Well, welcome to the talk on Awesome Web Media. My name is John Pallet. I'm a product manager on the Chrome Media team. And we're going to talk about several topics today. We've got a great talk. For my part, what I'm going to do is talk about a few updates in the ecosystem as well as API updates and changes in Chrome. After that, Jennifer will go into a really important topic of web media consumption, which is multitasking. As more and more viewers are using their computer not just to consume media, but also to do other things at the same time, this becomes a really important topic. And finally, Zoe is going to give an update on AV1 video compression. I do not want to steal her thunder, but it's pretty amazing stuff, and well, she'll cover more details later. If you attended I/O last year, you heard us speak about how this is the decade that has really transformed consumption of media, particularly in the video space, and the web has been a big part of that. Every day, 30,000 hours of video is consumed in Chrome. That's just video. That doesn't even include audio. There is a massive amount of media consumption across a very wide range of sites. And the ways that users are consuming that media is continuing to change. And that's driving new APIs that we and the Chrome team need to add and support. For example, progressive web apps have actually made an interesting difference for media companies because it gives them a way to get to users that have limited storage capability. It lets them get to them without requiring app install. For example, Instagram doubled their retention of web users when they launched the progressive web app last year. Another important case that's become relevant over the last few years on the web is offline media consumption. As more and more people get access to mobile devices, they really want to watch media or listen to media. And they want to do it even in places where internet access isn't available. This is really important in countries like India. And sites like voot.com are adding support for offline playback using some of the new web APIs. So in this case, what the user can do is select download, select the quality level that they want to pull down to their device, and then after it downloads, they're able to watch it offline. This is all starting to really come together, partly because of progressive web apps, and partly because of the underlying media APIs that make it possible. Now, we covered a lot of this last year at I/O, and for those of you who couldn't make it, the real message was that the mobile web is really ready for media. And in fact, you can do great things with media playback on the mobile web. There's a representative sample of what's available in the link above, and I'd encourage you to check it out. But for this talk, we're going to talk about some different things. And let's talk about desktop. What I want to do is talk about a recent change that addresses something that users have been complaining about for years, and that is autoplay. When a user first goes to a site and it unexpectedly plays audio, that is not good. And in fact, we can track this. And we know that a significant percentage of media that starts playing when a user first visits a site, without them interacting with the site at all, gets shut down within 6 seconds. And that's shut down either by a pause, or closing the tab, or muting, or doing something like that. We recently launched a new policy in Chrome to address autoplay. The policy applies when the user first arrives to the site. So this does not take effect after they've interacted with the site. If they click on the site, if they tap on the site, the autoplay policy is not being applied. But the policy applies when a user first arrives at the site. When a user arrives, muted autoplay is always allowed. So if you're wondering, okay, what can I safely do? The answer is you can do things that don't play audio. And if you have a video element, you can play it. There are a few cases where you can also play audio when a user first arrives. Of course, after a click or a tap, it's fine. You can play audio. But when a user first arrives, there are a couple of situations where you can play audio. The first is if your app is a progressive web app on mobile, and the user is launching it or has it installed from the home screen. In that case, when they launch a progressive web app, autoplay with sound is allowed. The second case on desktop is that Chrome is learning which sites users go to, and it looks to say, okay, wait a minute, if a user is going to this site and playing media most of the time they visit that site with sound, after a click or a tap, they probably want media with sound on that site. And so over time, as the user browses, Chrome will identify those sites and say, okay, we'll allow autoplay on a site where the media is usually being played with sound. This is actually an interesting case where Chrome does have the ability to personalize the experience for the user. And in fact, we launched this a few weeks ago, and as I mentioned, we get a really strong signal about autoplays that are not wanted. We know that the ones that are shut down quickly are the ones that users don't want. And when we looked at the results after this launched, what we saw was that about half of those autoplays get blocked. Now, that's not 100%. That's about half. Now, why only half? It's partly because Chrome is learning, and it doesn't always get things right. But it's a massive user benefit. I mean, we just cut out half of unwanted autoplays when users first go to sites. But for you, the developer, what this means is that you cannot always expect that audio will just work if you start playing it when the user arrives at a site. What this means is that when a user lands on your page, you will not know whether autoplay with sound is going to work until after there's a user gesture, a click or a tap. After a click or a tap, you're fine. But when the user first arrives, you won't know. If you're using a video or an audio element, the way to detect this is to look at the results from the play promise. You can tell by looking at the results whether or not autoplay started, and if it wasn't, if you tried to autoplay something with sound, you know that you can then try to play without sound. If what you're doing is hosting embedded videos, so videos that are in cross-origin iframes, and you want them to have the ability to autoplay in situations where they're allowed to, you'll want to add a new attribute to the iframe, the allow equals autoplay attribute. Now, this does not mean that embedded videos can always autoplay. What this means is that if you have an iframe on your site, and your site gets the ability to autoplay, then the iframe will get the ability to autoplay. If you do not include this attribute, any embedded videos in that cross-origin iframe will not be allowed to autoplay. Even if they say, we want to autoplay, they will not be allowed to do it. The policy will prevent that. So if you're embedding videos and you want them to be able to autoplay in sound when Chrome would allow it, make sure to use the allow equals autoplay attribute. The final topic I want to talk about here is web audio. What we're looking at here is an example of a web audio site, and it's reasonably typical, which creates the audio context on load. That's the top half of the code, up top. Now, what the assumption is here is that audio will always work when the user first arrives at the site. And as I said, that's no longer a valid assumption. Now, the good news is that what will happen under the hood is something that you can react to with only a small change. If you start an audio context and you don't know whether or not it's running, what you can do is look for a user interaction on the site, a click or a tap, and then call resume on the audio context. At that point, the audio will continue to work. The other thing you can do, and I don't have the code sample up here, is you can actually check the state of the audio context to determine whether or not it was blocked by the autoplay policy. Check the state. If it's running, then audio is playing. If it's suspended, then it's not. And that gives you an opportunity to do things like update mute controls to reflect whether or not audio is actually playing. I want to pause for a second to say that, our team is working very hard to improve things for both users and developers. As part of that, I want to acknowledge that we could have done a better job of communicating this policy change to developers who are using the Web Audio API. If you have any questions on this particular change, we are available both at the Web Audio office hours at 12:30, and in addition, we have media office hours today at 6:30 and tomorrow at 1:30. And if you're not here at I/O, if you're watching at home, or if you want more information about the policy changes, the link on the bottom on this slide has everything I just talked about. It also has more information that you will want as you're debugging your website, including instructions to completely disable or completely enable the autoplay policy so you can try out the different user interactions and different experiences. If you don't have this link, or if you don't get a picture before I move to the next slide, you can also go to developers.google.com and search for autoplay. Now, let's talk about what we recommend as far as what the user experience should look like. The ideal situation, from our perspective, is that when users arrive, and if you're not allowed to autoplay with sound, mute the media and play it to drive user engagement. And then when you get a user gesture, ideally give the user a control where they can unmute the media and they can turn on the sound. Tapping or clicking on that control will give you autoplay policy, and it will allow you to start playing with sound. Another alternative is to move to a click-to-play model, so capture a user gesture and then start playing sound. This is common. We've seen this for a fair number of video sites. It will also work under the current policy. And that's it for autoplay. So now let's switch to Jennifer, who's going to talk about something completely different, which is multitasking.
Thanks, John. Hi, my name is Jennifer, and I'm a software engineer on the Chrome team. We've always multitasked while consuming media. This could be anything from watching a movie while responding to emails to listening to live sports commentary while cooking. In fact, some of you on live stream may be tuning in while doing something else. Now, as we started to spend more time on our devices, multitasking has evolved, where the screen that we're using may also be the media screen, or at least the one used to control it. Last year, we introduced the Media Session API, which allows you to show metadata and images on lock screens and on wearable devices. This experience is great for users because they'll know what's playing and they'll also be able to control it. So let's take a quick refresher on how we can use it. First, we'll check to see if the device or browser supports Media Session, and if so, we'll use it. To make things appear, we simply need to provide the metadata, the title, artist, album, and artwork. And that's all you need to customize the media notifications for your web app. We can also set up action handlers to respond to these controls: seek backward, seek forward, play, pause, next track, and previous track. We may also want to control the playback state. So if you're serving custom controls, you can also reflect the media session state outside of the lock screen or the notification. Now, what about the desktop experience? Personally, I spend the majority of time on the computer consuming media. At the same time, I like to keep busy, such as messaging friends or reading the news. I find that whenever I want to watch a video on the computer, I'll resize the window to be really small and then move it to the corner of the screen so it doesn't get in the way of everything else I want to do. At the same time, I struggle with inevitably covering that window with one of the many other windows that I have open. Sound familiar? Today, I'm excited to share that we're bringing picture-in-picture to Chrome. The floating window will appear on top of other windows, allowing you to consume video while continuing to interact with the other content on your device. You'll also be able to interact with the window, such as with the play-pause controls, resizing, and moving to the window to your liking. You may remember that last year, we launched picture-in-picture on mobile with Android O with the native API. Today, we're building a web API that will allow developers to create and control the experience around picture-in-picture. This will be available for Chrome, on desktop, and on Android. So let's take a look at how we can use this. First, we'll need two things. We'll need the video, and we'll need a way for the user to interact with it. Today, we'll use a button. To start us off, let's enter picture-in-picture. We'll start by adding an event listener to our button. And when the button is clicked, our video will request to enter picture-in-picture mode. But why stop there? Let's make this button toggle entering and exiting picture-in-picture. We'll first check to see if the document's picture-in-picture element is our video. And if it isn't, we'll send a request to enter picture-in-picture mode. Otherwise, we'll leave, which means that the video will appear back in the original tab. The request picture-in-picture function returns a promise, and when if our video fails to enter picture-in-picture mode for any reason, we should let the user know. Showing the user feedback is a great way of letting them know what's going on. We can also listen for two events: enter picture-in-picture and leave picture-in-picture. By setting event handlers, we can define the experience for our users, such as showing other content on the page more prominently. This could be anything from showing a catalog of videos that the user could later watch, or surfacing a live stream chat. And finally, in cases where picture-in-picture is not supported, we can hide the button so that the user doesn't try to interact with it. While picture-in-picture is still under development, you can check it out today on Chrome Canary with these flags enabled. The first one will enable the access to the web API, while the next two will be used to enable the feature. You can also find out more about the API and implementation status at these links. Now let's say we have multiple screens. Imagine if you were presenting in a meeting and you wanted speaker notes. Or you wanted to share photos and videos to a large group of people, but you only had a small laptop. Presentation API makes displays such as monitors and TVs available to the web. Previously, this was only available for remote devices such as Chromecasts, but today we now also account for wired displays such as HDMI monitors. With Presentation API, we can build experiences for our users to see and control local content while presenting something else on the other screen. And in other words, we won't just be mirroring what's on our screen to the other monitor. Let me walk you through how to use the Presentation API to present a web page on a secondary screen. There are two components needed to get this to work: the controller and the receiver. The controller is the page that we'll use to interact with on our primary screen, while the receiver contents will be displayed on the other screen. And today, we'll call these components controller.html and receiver.html. So let's start by putting together a controller page. First, we'll create a presentation object, which will contain the URL that we want to show on our secondary screen. This could also be an absolute URL, or we could also pass in a list of them. But today, we'll just use receiver.html. With our presentation request, we can get the availability of the displays, or the second screens, and handle them however we want. We should also continue to handle display availability changes by adding an event listener for the change event. This might happen when monitors are disconnected, or we move to a network without devices. To show a presentation display prompt, we require a user gesture, such as a click on a button. And with that in mind, let's start a presentation request when a user clicks on our button. We'll wait for the promise to resolve once the user selects a display. This promise will return a presentation connection, and when that happens, the page that we passed in earlier, receiver.html, will be presented to the other display. Once we have this active connection, we can do two things. We can either close it or we can terminate it. Closing the connection allows us to reconnect later, and terminating the connection means that it's gone for good. So how do we reconnect to our presentation? We do this by simply calling reconnect and passing in the presentation ID of the previous presentation connection object. And there are two options of how we want to handle this. We can either automatically reconnect when the controller navigates, or we can reconnect when the user clicks on a button. We can also register event handlers for the presentation connection events: connect, message, close, and terminate. And with that in mind, we now have the components ready for our controller to work. Next, we want to have the controller and the receiver interact with each other. So on the receiver side, let's first retrieve all the existing connections and listen to any incoming ones. And we'll keep track of these as they come in. Every time we add a connection, we'll add event listeners, such as message and close events. And so what does this look like put together? Our team published a sample web app called Photo Wall, which showcases the presentation API. We use the controller to select photos that we want to add to a slideshow, and we use the receiver to present it. To get us started on the controller, we'll use the presentation request and retrieve the list of receivers. We'll then select one to create a presentation connection. And once we're connected, the controller will prompt us to add images to the slideshow. And what's more interesting than searching for photos of dogs? Here, picking a photo will add it to the queue of images to share on their slideshow. And how do we get that information to the receiver? Calling connection.send will send a message between the controller and the receiver, and vice versa. This message could be a string, a blob, an array buffer, or an array buffer view. And in our example, the controller will send the description, or the name of the dog, as well as the image source to the receiver. Upon receiving this message, the receiver will then handle it by updating the slideshow to include the image. So what happens when we send Peanut, Nuka, and Elsa to the receiver? We'll get something like this. And that's all you really need to get started with Presentation API. This API is already available on Chrome, so be sure to check it out. So media session, Presentation API, and picture-in-picture. We believe that these are all great additions to the web media story. You can check out all the APIs at these links. And we always love feedback, so let us know what you think. Now I'll hand it back to John.
think I heard somebody go whoop for picture-in-picture, whereas I was saying, I didn't know you were putting my face up there. Thanks for that. Anyway, so the presentation API, and that's actually a really interesting example of how Chrome can work across multiple displays. And so if you have multiple displays, Chrome can use presentation API. There's another capability in Chrome for doing things with other displays, and that's Cast in Chrome. Cast in Chrome will let you play media or mirror your tab or your desktop to cast devices such as Chromecast or a TV. Now, let's talk about mirroring for a second. The thing about mirroring, like if you're mirroring a tab, what you're doing is you're rendering the tab, and then you're capturing it, and then you're encoding it, and then you're sending it over to the remote device. And if you're playing media, that's an awful lot of work just to capture the media, grab it, encode it again, send it over to the device, which is then going to decode it. There's been an important change here, which just landed in Chrome. During tab mirroring, if the user goes full screen with a video, Chrome will send that compressed video directly to the device. And that eliminates most of the steps that I just mentioned. There's no need to decode, there's no need to capture, and there's no need to encode. Chrome is still in the middle. It's sending the video frames directly to the device, though, without modifying them in any way. From a user perspective, they'll still have playback control in Chrome like before, but instead of the video playing on their local display, they'll see this. Now, this is good in most cases, but there are some cases where you won't want Chrome to remote a full screen video. For example, if you're doing 360-degree spherical video, what you're likely doing is taking a canvas and rendering with WebGL on top of it a piece of geometry with a video mapped onto it, and that's good. Behind the canvas, some of you might have a full screen video element which includes the entire video, which is effectively a texture map. And you probably don't want that video to be sent to the television. If you see this on your site, it's very easy to prevent it. There's an attribute you can add to any video element called Disable Remote Playback, and Chrome will respect that. So if you don't want media remoting to work on a video element, add this attribute. So why are we doing this? Well, it's because it's a significant optimization and it happens automatically. If you look at the middle metric, you can see that the CPU consumption goes down dramatically because we're skipping a decode and a compression step entirely. If you look at the top two metrics, especially the top one, you can see that playback smoothness increases significantly and freezing gets better as well. And then the bottom two metrics show that the video quality itself gets better because we're not decoding and re-encoding the video. The less that Chrome touches a video, the better, and it lets you send the original compressed video directly to the device. Now, of course, that original compressed video is only going to be good if your settings are good and the algorithm you're using for compression is good, which is a really good segue for me to pass it over to Zoe, who's going to talk about updates on AV1.
Thank you, John. So today, I'm going to talk about the new video codec, AV1. Video has been one of the significant experiences over the web, and that has been mainly manifested by the extensive bandwidth usage by the users. Compression are the technologies behind the scene that power this growth. So why video codec mattered? Let's look at an example. Here is a 5-minute high-definition video with the size of 300 megabytes. This is what we observed. Indeed, it's a compressed version, as opposed to its uncompressed version, which is as large as 25 gigabytes, almost 100 times large. For a 4K video, it could be even 10 times larger. Therefore, compression are the technologies that is requested. Without compression, there's almost no possible for any video service over the internet, and our users notice the result. Back in 2013, Google rolled out its previous video codec, namely VP9. As opposed to, at the time, state-of-the-art codec 8264, VP9 has achieved on average 30% performance gain. So here is a global map of the YouTube watching time of VP9 compared to that of 8264. As can be seen from the slide, the darker of the slide, the darker of the color is the longer watching time attained by VP9 as opposed to 8264. The reason for longer watching time of VP9 are mainly threefold. First is a fast loading time. Secondly, it's a lot less buffering. And thirdly, which is the higher quality delivery. So the success of VP9 has been responded by our users with their longer usage. The success of VP9 has not gone unnoticed. The most recent video codec has been developed by the so-called Alliance of Open Media, short as AOM. They named its first generation codec as AV1. AOM, as can be seen from this slide, has included the top media and technology in companies from almost every aspect of the industry. So here you can see we have the web platforms, content providers, and hardware makers. There's three goals of AOM to develop AV1. First, we want to develop a codec for the web, even though that has been increasingly overlapped with the TV, security media, and all the other industries. The second target of AOM for AV1 is to have open, royalty-free codec. This is a significant change for the industry that has been mainly stalled by patents. And the last goal of AOM is to have a real deployment. So it's targeted to be supported widely across all platforms and to be developed at a much faster pace. So here's a landscape, pretty complicated, because that represents one of the major areas that we have been touched during the development of AV1. We have developed over 100 compression technologies for AV1. Today, I'm mainly going to talk about two of them. We're going to have a little bit deeper dive of the following two technologies. The first one, we name it as wedge-based interprediction. Let's look at an example. So here's a clip from here's a frame from a video clip. And there's the next one. So for these two successive frames, it can be seen there's a lot of similarity between them. The major task of a video codec is to remove the similarity between them. One of the most commonly used tools is called block copying. So you can simply copy the previous block for the current one to achieve a compression ratio. However, you look closely, this shape of the block, which is square, is not aligned well with the object boundary. So if you look closely, somehow, if we can introduce a wedge-based shape, which can be a lot better aligned with the boundary of the object existing in the frame, there could be a lot of potential that we can obtain a further compression gain. Therefore, here comes the compression technology that we refer to as wedge-based interprediction. This is the first time that has been introduced by the video codec. AV1 for the first time introduced both the square-based and rectangular-based wedge codebooks for the interprediction. Because it's a better alignment with the boundary of the object, as we just showed, there is a significant gain that has been obtained. The next tool we're going to talk about is about the work motion. Let's look at another example. So here is a frame, again, from a video clip. And there's a rotation for the next frame. So how do we describe this rotation and then to obtain a compression? So the general user tool is to describe the motion info of all the blocks that covers this rotated object. It can be seen there's a lot of information that we need to signal. If we look closely, there's another way. If somehow we can only signal those motion info for those blocks located in the top left boundary of this rotated object, well, if there's a way that we can derive the motion info for all the remaining blocks of this object from the surrounding blocks within the cursor window, there could be a lot of potential for us to obtain a better compression. There comes another tool introduced by AV1 named the local warp motion. So AV1 has used a mathematical model here as example, a fine model to first horizontally and then vertically derive the motion info of the current block from those motion info of the surrounding block within a cursor window. In this way, a more effective and efficient compressed technology are obtained so that a better code gain can be achieved. So summarize all the technologies that we have introduced in AV1, here's the result. To compare AV1 with its predecessor VP9, generally, there's a gain of 30% performance improvement for AV1 for both two scenarios, the video on demand and the live streaming. Here's another presentation of this result as for comparing AV1 as opposed to VP9 obtained by Google. An independent evaluation has been conducted by Facebook, mainly on top of their user-generated content uploaded to their Facebook website. A consistent gain has been attained and achieved can be observed from this slide. Furthermore, you can observe that with the increment of resolution, a larger advantage of AV1 can be observed as opposed to VP9 and another state-of-the-art codec H.264. It can be expected that AV1 can have a larger gain for larger resolution. A last evaluation that we are demonstrating down here is conducted by Moscow State University. MSU indeed rolled out an extensive comparison result report for almost all the top video codecs they collected. They usually conducted a very extensive comparison, especially considering different categories, such as the encoder speed, the quality metrics, as well as some of the rate control strategies, and also the resilience performance of the codecs. This year, they include a comparison with AV1. As can be seen closely, they report a consistent result for the advantage of AV1. Next, I'm going to show a demo to compare AV1 as opposed to VP9 on coding the same video clip to achieve the same quality level. So the left part is encoded by VP9, the right is from AV1, and the result of compression are shown in the slide. I think everyone has observed the light speed rate that has been resulted from AV1 as opposed to VP9. And the current status of AV1 is we have already selected all the coding tools, and we have frozen our code base, and we have released our spec. The next step, it is expected that Chrome will support AV1 later of this year, and for the hardware support, it is expected in 2 years, in the year 2020. For everyone who's interested in AV1, you're welcome to visit our website showing this slide. From there, you can download the code base, as well as you can access the details of the specs. Because we are open source community, you're welcome to evaluate as well as to contribute. Next, let me hand it back to John.
Thanks, Zoe. AV1 is pretty fantastic. We're really excited about the bitrate savings, and the storage savings that it is going to offer. And we're also really excited for it to start rolling out. But at the beginning, it won't be available everywhere. And in fact, if you look at even VP9 and H.264, there are varying levels of support for codecs, where some devices do hardware decoding, other ones do software decoding, and this can affect how smoothly and power efficient the video decoding can be, how efficient the playback will be. Fortunately, there's a new API available that will let you detect this ahead of time, and then what it lets you do is ask the browser not just whether decoding is supported, but how performant it will be. Let's see how it works. So in this case, what we're going to do is create a media configuration, and we're going to test Opus Audio at stereo and VP9 video at 1080p. And what we'll do with this media configuration is we'll pass it in to the Media Capabilities API and ask it for information about the decode. Now you can see that you get 3 values back. The first is, can it decode? In a lot of ways, this is kind of similar to can play type, but it gives you a strong signal as to whether or not the codec is even supported. The other 2, the second and third, smooth and power efficient, are brand new, and they're really exciting. They will tell you whether or not, for example, is it going to be smooth? Can the GPU or the CPU keep up with the resolution and the frame rate that you're going to be providing it? It's really new, and it can make a big difference. How much of a difference? Such a big difference that YouTube ran an experiment with the API, and what they found was that by surgically adjusting the experience for just a few users, the improvement was so big that it affected the overall average across all users. So let me explain what I mean. You can see that it improved mean time between rebuffers by 7%. It improved the rebuffer rate by 10%. Those are big aggregate average changes. But it only adjusted the average video height by 0.4%. What that means is it actually wasn't affecting a whole lot of users. It was only focusing the ones that actually could have used a change. And it improved their experience a great deal. So to summarize, this is worth looking at right now, and it's going to become more and more important as AV1 becomes available. So we've covered a lot of things, and some of you may be wondering, that's a lot. How can I get access to all of it easily? There are a lot of answers to that. I want to cover 2. The first I want to talk about is the open source Shaka player and the packager, which offer an easy way for developers to adopt these best practices. We at Google are constantly updating Shaka, and if you're using it, you're going to get a lot of these new features we've listed here automatically for free over time. For example, recent improvements to the Shaka player with version 2.3 include support for HLS live video and on-the-fly transmuxing between transport streamed and fragmented MP4. This summer, the team is planning to launch a player user interface layer, which will make it a lot easier to deploy the player. On the Shaka packager side, version 2.0 added support for VTT and subtitles. Support for creating content that is ready for ad insertion is also coming in version 2.2. So both Shaka Player and Shaka Packager give you a way to deploy easily, but then also keep up with changes as they roll out, and new APIs as they roll out. Similarly, the AMP team has been working to implement many of the best practices and looking at some of these APIs as well. And these are taking effect in AMP video, as well as other related video tags in accelerated mobile pages. On the user interface front, rotate to full screen is already done, and they're working on in-page docking, which will be coming soon. So again, this is another way that you can get a really great video playback experience without having to write everything yourself. For both Shaka and AMP, the goal is to make it easy, so they're both worth looking at. More generally, as I mentioned before, this really is the decade of video, and as consumption patterns are changing and they're evolving, it does mean there's API changes and new APIs to learn, but it also means that you're going to have more meaningful experiences for users, and we'll see watch time continue to increase, whether it's picture-in-picture or offline playback or cross-device playback. And this gets even more exciting when you layer video compression advances on top of it, where you don't need as much bitrate to get great quality, or you can send higher quality video at the same bitrate. And you also don't need as much storage on the device if you're doing offline video. We are really excited about what's coming. It's a very exciting time to be in media, not just as things become higher quality, but as some of these new use cases evolve and people start consuming in new and exciting ways. So with that, thank you very much for your time. As I mentioned before, we have web audio office hours tomorrow at 12:30. We have media office hours today at 6:30 and tomorrow at 1:30. And we'll also be available for questions at the web sandbox. Thank you very much.